CUPV, Cradle-to-Cradle Sustainable PV Modules.
Well, of course, many people know that solar energy has a huge potential on a global scale. It can easily cover our entire energy demand. So we are now moving into the very large scale, the terawatt scale, within a decade from now. This is going much faster than many people anticipated or thought possible even.
We've heard about the growth in solar energy. Let's look at how much energy the sun can actually give us. Every hour, the surface of the Earth receives more solar energy than the entire world uses in a year. Let's compare solar energy to other types of energy. Let's say this cube represents the energy the world uses in a year. This cube shows how much energy you can produce from the uranium that's in the ground. These show how much energy we can get from conventional fossil fuels. Now, look at what the sun gives us every year. Climate change is one of the major reasons why the European Union has set the objective to significantly reduce greenhouse gas emissions. Electricity will need to contribute more to the total energy mix, and renewable energy will play a major role in electricity generation. At present, studies project that solar electricity may contribute up to a quarter of the final electricity mix. Photovoltaics, also called PV, is the direct conversion of solar radiation into electricity. What is a PV system made of? Let's look at a typical PV system installed on the roof of a house. It consists of many PV modules, and each PV module is composed of a number of silicon solar cells. In a solar cell, the blue area is the active material to convert sunlight to electricity, and it's commonly made of silicon. Another essential component of the solar cell are the metal contacts, which carry the electricity out to be used. They are made of silver.
Until recently, the main drivers for the development of solar energy and photovoltaics in particular were cost reduction and enhancement of the performance, the efficiency. But now that solar energy is on the verge of becoming very big in Europe, but also on a global scale, it becomes very important to also address the sustainability. You could say solar energy is inherently renewable, but it is not automatically fully sustainable.
For photovoltaics to be sustainable, there are three main points we have to address. We don't want to use scarce materials. We want to have a low energy consumption and a small carbon footprint in the manufacturing of the PV module. And we need to recycle the PV modules at the end of their life. Let's look at our first point and see whether or not we are really using abundant materials in our PV modules. Silver is the scarcest material used in the conventional silicon solar cells, and it's in high demand for many other uses. How scarce is it? Currently, a solar cell uses 250 milligrams of silver. In 2012, the world's silver mines produced 24,000 tons of silver. To meet the EU targets in 2050, PV modules will need to use almost twice the 2012 global mine production of silver, which is about 10% of the estimated silver reserves in the entire world. This is too much. Europe is not the only continent that will install PV systems, and silver is used in many other industries, so it's not a sustainable approach. Other metals can be used to replace silver. Copper is a very good candidate. Copper is almost as conductive as silver, and is more than 1,000 times more abundant. To meet the energy goal of the European Union, much less than 1% of the 2012 global copper mine production will be needed. And this is only about 0.006% of the estimated world copper reserves. Still, replacing silver by copper in a solar cell is not so trivial.
Now, indeed, to deposit copper onto a solar cell, a different process is required than what is currently used for silver. Now, MECO has a lot of experience with depositing thin metal layers in the electronics industry. Now, this process is called plating. Now, in a plating machine, the solar cell goes from one chemistry bath to the other, and each chemistry bath deposits a different metal. This always happens in a so-called pattern with fine lines. Now, to accomplish actually these fine lines, you print a seed layer with exactly the same pattern. Now, in the CUPV project, there's a unique combination between ECJet, which makes industrial inkjet printing equipment that actually prints down this seed layer by using inkjet printing. Now, subsequently, Mako comes in with our plating tools, and our plating tools plate up these seed layers with copper. Now, this all may look very simple, but in fact, there's quite some challenges in turning this into high-performance solar cells.
Now, for our second sustainability point, let's look at the energy consumption and the carbon footprint of the PV module. Energy is required for the materials and manufacturing of the PV module. About 65% of the energy is used to make the silicon wafers, the base material of the solar cells. The solar panel has to run for about 1.5 years to produce the same energy that was used for its manufacturing. This is called the energy payback time. By reducing the thickness of the wafer by half, the energy payback time can be reduced from 1.5 years to about a year. For a typical European family PV system, the energy saved for the production of the panels can drive a car from Paris to Beijing. Using thinner wafers is difficult with conventional technology. Thin wafers are fragile and break easily during panel manufacturing. A technology for a module with back contacts developed by ECN and Eurotron can handle thin wafers.
The current way of manufacturing is that the solar cells are connected by soldering. During this process, you will face problems with yield, especially when you use very thin cells. The Eurotron technology is based on the backside contact technology. This technology is, for example, developed by ECN and IMEC. The cells are connected by a little bit conductive adhesive on the back of the cell to a backsheet foil, and in the process of Eurotron, the cell will only be picked up one time. This makes it possible to use thinner cells, and on the end to use less silicon in a complete solar module. Also, you will have and see a higher power output of the module.
Let's look at our third sustainability point: recycling. Average solar modules can produce energy for 30 years. At the end of their lifetime, the materials and the energy used to manufacture them will not be lost. PV module manufacturers and installers have established an organization called PV Cycle, which is actively collecting old PV modules at hundreds of collection points in Europe for recycling. Up to 90% of the module weight can be recovered to be used in new materials and products. Current recycling uses existing solutions for recovery and treatment. In the CUPV project, 4 partners will investigate new approaches to recycling, which recover the materials in a more economically valuable state. In 30 years, there's going to be a lot of PV systems installed on almost everybody's house. That's going to be a lot of material. We have to make sure that we're using materials that are abundant, and we also know that in 30 years, we're going to be facing a lot of PV panels that are coming to the end of their life. And we have to be equipped with a solution on how to handle that. So we're starting now by coming up with new ways of recycling that can make the most out of these materials in the most energy efficient way. In this consortium, we have the know-how of technical plating. We have the module expertise of ECN and Eurotron. And of course, we have the recycling experience of PV Cycle. And we're putting all this expertise together, and we're very optimistic that we're going to be able to meet our goals. So we have to start now so that we're ready in 30 years. The CUPV project aims at designing PV modules to enable efficient recovery of the solar cells, aluminum frames, and glass plates. The junction box can be collected as electrical waste under the European Union's WEEE directive.
So I think this is an example of the new phase of development where it is about cost, performance and sustainability. I'm very happy and proud that ECN is in this project. It also fits perfectly our strategy, which has also included sustainability of the technology as a key component. To do this with partners in Europe is of course the best way to achieve fast results. And I'm looking forward to the results of this project and also to collaboration with the other institutes and companies in Europe.
CUPV is a 3-year R&D project supported by the European Union. For more information, see www.sustainablepv.eu.